Okay, everybody, welcome to Delphi Tech Tip Thursdays. I'm Rick Escalambre. I'll be presenting today the good and bad of Mode 6. This is not listed as by parts, but if you were with my tips on completing drive cycles last time, and this Mode 6, and the one we're going to do on June 25th is Mode 9, in-use performance tracking. We're going to tie this all together in and show some case studies of how you can apply all this, what I call driver seat diagnostics. One thing I'd like to say is we had an issue with the Zoom this morning for the Eastern time zone. If we should drop out, hang tight. I'll try and log back in, but I might just keep the flow going. I'm recording this, and that means I have all your emails. So if there is a problem, I'll upload it to my YouTube as an unlisted video and email you the links. But hopefully all will go well this next hour. So sit tight and let's enjoy the ride. Okay, first of all, what are we gonna? Whoops, let me get up. I'm trying to get my picture off the screen. I don't need to be on. There we go. What are we gonna do for the next hour? First of all, what is Mode 6? And what I always tell people is this is another tool in your toolbox that you don't use every day. There's good of it, there's bad of it, and at one time used to say there was ugly of it. And it can be at times, especially if you're working on older cars. Most of the newer stuff is improved, and I think it's really important that Mode 6 be learned with a little bit of respect, because under the new OBD on UDS, this is going to be pulled together with DTCs into groups, and it's going to be very important that you have a good understanding of it. There's only so much we can do in an hour, but I think in this hour we can give you a good solid foundation and a good plan to approach in this. We'll touch on the Mode 6 terminology a little bit. We'll look at pre-can cars, especially the Pacific time zone, where we have probably a lot more pre-can cars in California and in the Western region than we do anywhere else. But it still applies. There's still those cars out there. I want you to know it, respect it, and show you how we got to where we are with CAN standardization, which has improved it tremendously. And are there still problems with it? Absolutely. But the idea is better to know more about it than less. And we got a couple little short case studies in the end to show you some things that how this might apply. So let's get the show on the road. And first of all, Mode 6 is one of 15 modes available in Global OBD2. It's mainly for the non-continuous monitors such as O2, O2 heater, secondary air, evap, CAT. But it does include continuous monitors when we come to CAN, because it includes misfire and it includes fuel system. And I think it's important that you take a look at those, especially the misfire ones. I'm going to show you how you use that to your advantage. Mode 6 is a request you make of the PCM. And basically think of it this way. When you meet somebody, you're doing a handshake. And when you have that handshake, there's a communications there. Well, Mode 6 is the same way. When you enter Mode 6, you're making a handshake to pull out the most recent information from its memory to your scan tool. You have scan tools that are going to do non-cyclical and cyclical requests, and I'll explain that as we go along. I think that's important to understand. It's just a scan tool, the way it's set up. Not all of them will do it. And not all of the continuous tests or non-continuous tests need to be used all the time, especially the non-continuous tests. To look at them over and over and over again it's just not worth your while. But the misfire will be. Mode 6 is recorded after a monitor test runs, and I want to make that clear because it does not mean that it passed. It does not mean that it completed. What it means is it may have recorded, and it could be in an averaging mode, and it might take multiple more trips to be able to decide an average. It's the best way I can explain it to you. Mode 6 is updated during the same trip. Occasionally on older cars, you might have to cycle the key off and turn the key back on to get an update. But as a whole, it's being updated during the current cycle. And at the end of this, I'm going to show you that some monitors tests run multiple times per key cycle, and numbers will change consistently. And I'll show you in a little quick video I made off a scan tool I have. The history of Mode 6 is very simple. If everybody could have done it as Ford did it in 1996 on their own IDS tool, we wouldn't even be sitting here discussing this today. Ford did it well. They named things. They identified them properly. You have your min, max, your value. They really had their act together in this. And what you're seeing on the screen, we're going to see on other scan tools in CAN cars with I think some really good information in there. We'll get into that a little bit later. You've all seen this, I'm sure. This is Snap-on. We go into Mode 6. We are fortunate in this case. It is telling it's the O2 monitor. It is telling us it's a MID, which we need to know right away. And MID means we're working on a CAN car. We do know that the value is going to be in milliamps, which we didn't have before. And in this case, we do have a min and a max. And the min and the max can be a good thing, and it can be a bad thing if people use it that it's close to the min, close to the max. I say let the DTC be your guide, because you don't know how long it's going to take to get to that min or exceed that max. And the word pass, we'll get into that a little bit more, but that was deceptive on the older cars. I do like Autel, the way they do it. Anytime you can generate a report and do it quickly, also gives you a database. If you search Mode 6 information, you know what I'm talking about. We're going to talk about that a little bit later and where to find it. The issue is it's pretty sketchy at times. So if you can collect this kind of data off of a car you're working on and put it into a folder on your computer for that particular car, you've got a huge database right there. And I'm a believer in the way you learn this stuff is you test known good cars. Because to know bad, you got to know good. And the help on this can be sketchy at times. Mode 6 terminology, the best thing I like on this page is you can help turn it into dollar signs for you. Understanding these things, respecting it, knowing when to ignore it, when to maybe pay attention to it is really the important parts of this whole presentation. MIDs, MIDs, monitor identification, came along with CAN, and that's what we see on our readiness status, our CAT, our O2, our EVAP, our secondary air, and on down the list. O2s, those will be the main group. And this is going to be important because when we get into the new system, OBD on UDS, everything is going to be grouped, and MIDs are going to be the start of it. TID is an individualized test within that particular group. The issue here now and in the future is these are not standardized tests. So what you see on one number on one manufacturer will not hold true possibly in another manufacturer in the way they complete the testing, the values they use. So you have to be able to look that up. And when we get into the new system, OBD on UDS, TIDs will be tied specifically to the criteria of a DTC. Currently right now, trying to find this, and we're going to take a look at it, can be kind of a helter-skelter thing. Component ID, we eliminated when we went to CAN. So on a CAN car, you'll see MID and TID. On a pre-CAN car, you'll see TID, test identification, which would be your EVAP, your O2, your CAT, etc. CID would be component identification. And some of us around this on this webinar have been in this industry long enough that if you give a tech a failure that's related to a component, some of them, you know what they're going to change right away. So that disappeared when CAN came along. Hexadecimal is the way all computers talk. You hear the number 65,535. Well, that's the possibilities we have. And it's like you building a stadium. You're going to make money on every seat in the place, and everybody has their own ticket. And then all of a sudden, 5 people have counterfeit, duplicate tickets. It messes you up. Well, hexadecimal is kind of the same way. Raw data is how that information is displayed to the scan tool on pre-CAN cars. I'll explain that a little bit more as we get into CAN cars. Manufacturer conversion, that was not available except on Fords when Mode 6 started in 1996. Toyota came along in their own cartridge with the conversions built into it. So when you looked at the Toyota software, you actually got the real value that the car was using. We've fixed all that in CAN, and I'll get into that a little bit. Test value, that's your result. That's what you're basing your numbers on. Results will be pass, fail, completed. There's problems on those on the older cars, especially pass and fail. I've seen cars that say pass, key was never on, which most of them did do that. I've seen fail where there's no failure at it all. That was a default. So we'll look at that a little bit later. And TLT, test limit, I'm going to show you an example of that. But basically on the next page here, it means that if a TLT is a 0, it represents a maximum limit. So let's say a typical older catalytic converter has to pass below 70% efficiency. That would be a 0. Say EGR flow has to rise 20 degrees Celsius once the EGR flows. That would be a 1. That means it has to be above a minimum. Be careful on your older cars when it says pass, because pass may not mean what it really means. And also fail doesn't, and we're going to look at examples of that. Those are defaults. I pulled up this one right away because some of us have dealt with this for years. Mode 6 pre-CAN was a can of worms. First of all, there's no standardization. 01 in this case was a catalytic converter on a V6 Lexus. So I can look at this numbering here and say, This vehicle right here has 3 O2 heaters. It has 1 catalytic converter, so I know it's a V6. So I got to play that out in my mind. I have 4 O2 tests, which TID02, which is the evap system. I have 3 heaters on the 04s, and I have 2 EGR flows, but there's still things missing in that. And again, that didn't hold true from one manufacturer to another. Then we had Honda, and if any of you worked on the older Hondas with the evap systems that were split, they used one code, 1456, for the rear of the system, and they used 1457 for the front of the system. This one code incorporated, if you look here, incorporated 9 tests. Okay, excuse me, 8 tests in this case, that could have run, failed, and set this DTC. The idea of the TID was to get you into a starting point where you might begin your testing. We've obviously refined that with more DTCs, and on these new systems, we're going to find them with subcodes, but this is how rough we got when it came to this. And I'd have techs say, yeah, I fixed my Hondas, I just changed everything. Well, you change everything, you're going to hit one of these right, and you got one of them right to begin with. When you see mid, we know we're on a CAN car. And we'll break this down as we go along. We're going to see more mins and maxes. Pre-CAN, we didn't see as many mins and maxes. We used to a max or a min. Now we're seeing ranges. Give you some working ground. And I heard once a good friend of mine said, think of Mode 6 as the best of the worst and the worst of the best. So you gotta really understand this and know what you're working with. And again, let the DTC be your guide. For CAN cars, the beauty of this is we have standardized it. For now on, if you see 01 and your scan tool does not give you the name, and some of them will not convert the names, and you see 01, you know you are working with Bank 1 Sensor 1. If you see 02, you know you're working with Bank 2 Sensor 2. Bank 1 Sensor 2. And if you see 0506, you are now working with Bank 2. Anything that says 21 or 22, 2122, you know you're working with your catalytic converters. So the standardization on this has really helped make things better. And on the next page, we've got other standardized mids, but the one I want to touch about, because we're going to look at it later, a good example would be misfire. We're going to find out that we have 2 misfire mids per cylinder. We're going to be looking at the last 10 drive cycles, and that's where we get an average. And we're going to look at the most current. Some of you might remember the old GM system. They use current and they use history. This is kind of a form of that, and I'll look at that later. But I think for techs to understand it, in Mode 6, this is a wonderful tool on CAN cars, especially the cars that have the intermittent problems. And I'll show you one later on a Toyota where being able to track this and see this without a light, and if I go over the OEM side of the scanner, there's nothing there when I need it. And when I go into the history here, I can actually see some history of the vehicle and get an idea of what may have happened before they showed up at my door. One thing I want to emphasize, on the pre-CAN cars, there was no standardization. No scan tool could have been big enough to hold all the different conversions and information and pass-fails for every car out there. It was a hit or miss. That's why they gave it to you in raw numbers and let you convert it over if you wanted to. And I'll show you examples of that, but I don't encourage you to go get a calculator out and convert them over. There's ways to figure things out in your mind by just using a little reasoning. But since CAN came out, the beauty of it is, in the CAN cars, Mode 6 and all reporting from the PCM to the ECM was standardized. And in Mode 6, they came up with 256 tables, and everybody has to report the same way. So if the PCM is reflashed, that has to be accounted into the data that's being sent to the tables in the scan tool. On the old cars, if the information was changed and there was a reflash, and you went to the manufacturer's page and look at the conversions, they may have been 100% wrong because they had been reflashed. So with CAN, this is a standardized way of presenting Mode 6, and everybody has to report the same way. Are there variations? Yes, somehow they slip it in, but the idea is you can count on it being more reliable than it ever was. And another little tidbit on these is, if you haven't been updating your scan tool in the last couple of years, remember, Global OBD2 will talk to anything. I've talked to as recent as a 2026 with some older software, and it doesn't care. That protocol has not changed. And so if you've got something beyond 2000, I would say stay beyond 2008 or newer, you can still use that scan tool. Think about that. Just a sample here I caught off of a Nova scan tool. You can see up top right away, we know Bank 1 Sensor 101. We've got a mid. So we know we're on a CAN car and we got a test ID. We're going to talk about these zeros here because they're an eye catcher. They're a clue that a test is not run. Whenever we clear the memory on a CAN car, mode 6, all three value, min and max, all go to zeros. Now, status should say incomplete. This one says okay. It is not okay. You want to have zeros. That means the test is not run. That can be a help for you in trying to find blockers when you're trying to run monitor tests, especially when it comes to O2, where they have a lot of tests, evap, where they have a lot of tests. I'm going to show you in a little bit what we call ghost monitors, where you have to be careful where the zero is not a problem. But in the next session in June, we're going to close all these up with some case studies to show you how you scour mode 6 real quick, looking for the zeros, and find out which test hasn't run. And if they're all zeros, you can't tell me, you could say, I can't get the monitors to run at all. But if I have all but 1 or 2 done, you've been driving the car properly, you just haven't been finished in the job. Okay, so mode 6 in CAN cars, this is what they look like after a memory clear, battery disconnect, etc. Reflash, if that affected that part of the computer. That means nothing is run here. And we're going to look at a couple of these as we go along later in the webinar. So just keep that in mind. Zeros mean a test have not run. Now, as everything, there's an exception to rule in our business, and one of them is right here. It's what I call ghost monitors. When we get the evap, a lot of times there's 2 tests per item. So if you look at the top up here, it says excessive vacuum limit. That test passed, but no problem. Well, if there was no excessive vacuum, that must mean the purge closed, it's sealed off. And in this case, it says purge valve stuck open. Well, since it passed the first test, it's okay that we see zeros here. So that's why I don't want you to get locked into the thing. If you see zeros, that's a blocker from the test completing. If you see zeros in evap, get the name of the test and think about it. And there's probably a counter test to that to verify the operation of it. If we come down here on natural vacuum leak detection, we have a chance to test it positive. We have a chance to test it under negative. Well, if it passes on the positive, there's no reason to test the negative, and vice versa. If there's too much pressure, or maybe pressure's a little low and it wants it to sit and cool it in a vacuum, then it won't run the pressure test, won't report it, and it'll go on to the vacuum test. Then the last one here, looking for restrictions in the evap line, it passed the first test. There's 0 pascals in there. There's no reason to run the blocking valve performance test. So when we're looking at O2s and things like that, we're looking for zeros to see what hasn't run. And I'll show you even when that isn't a zero, when you drive the car, you can see if it changes, and that'll clue you in too. So keep this in mind. There's variations to all of this, and this is one of them that you need to be aware of. And there's no books that talk about this. You just pull up this data and start looking at it and say, hey, Rick told me if there's a zero, there's a problem. Not an evap. Look at the name of the test and see what it's doing. Okay, reporting of it. Here we have one that's a max, which means it's a high limit. If we're at 6, goodbye, I'm gone. There's no way that thing is failing anytime soon. Okay? Now you can tell, based on the numbers, that in this case, we're working with a non-CAN car. Okay, and this one here, we're working with a CAN car, and we have a min and a max. We get a range. We didn't see much of that pre-CAN, but we see a lot more of it on CAN cars. And I want to caution you about how close it is to the number, whether you judge it as failing or not. I would never sell a job based on it being close to the number unless I've had some intermittent check engine lights. The mill's been on intermittently for that particular monitor, then I might take a look at it deeper. I'd make a note of it for sure, but be careful because we don't know how close we really are, especially in things like evap. How close are we in inches of water column or millimeters of mercury? How much more room do we have before it's going to fail? So let that be your guide. That's always been my rule. Now, what does this all look like? What does it mean? Here's a little chart I make up, and this is a good catalytic converter on a Ford. But let's say this Ford was setting a DTC, the mill was on, and it was sitting up here at 70%. What that's telling you is this cat has only got 30% efficiency left. Now, for everybody in California that might have done gas testing, emissions testing, you probably had cars that passed the tailpipe and they failed the mill. One of the reasons might have been is this limit here, so let's say this is a catalytic converter, is saying that, and if I calculated this out on this Ford, it comes out to about 70%. So if I calculate this forward, it's going to turn that mill on, light on, and it's going to set that DTC at about 70% uh, on the scale because it only has 30% of its efficiency left, which means it isn't capable of keeping things clean through all driving conditions. So many times that mill comes on at a number much lower than you would think because there's room to try and it'll still run, it'll still perform, but it's not 100% efficient. So this one's at 26. I'm moving on. Forgetting what the number means, I'm a little over halfway up the scale, which means this isn't going to fail anytime soon. So visualize this when you see mode 6, and 45 is not the max. When you see max on there, I'll show you one later. They can go over the max, no problem, and then go well over the max. Okay, where do I find this information? That's one of the things that we all battle. Do OEM websites have it? Maybe yes, maybe no. And if they do have it, did they do a good job of presenting it? And you know yourself in the aftermarket, some of you go right to the aftermarket subscriptions because you're more familiar with it. They're a little more user-friendly, where if you go to all the different OEM websites, there's no telling where you're going to find what and where. Everybody's a little bit different. But the OEM websites can be a start. Ford and GM, give you two examples, do an excellent job of it. Toyota does an excellent job of it. But there's some others that there's a lot to be desired. So I caution you on that, but that's a resource. We're going to look at one in a minute. Aftermarket subscription services, ALLDATA, Mitchell, Identifix used to do a really, really good job of Mode 6 where you could just go under Powertrain Management and you could find a tab for Mode 6. I'm finding that harder and harder to find on some of these. So once I pick the vehicle and I need Mode 6, I just do a search right at the top bar and search it to get me to Mode 6. And in the case of ALLDATA, if you run into a case where you really need it, they probably have it. You can contact them and they can send it to you. But some of them aren't listed like they used to be. It was much easier to find this stuff before. And I do occasionally, I'll do an AAI search, and I'm going to show you all three of these here in a second. So on this next one, this is the common one. And I didn't mention it, but I didn't put my website in this one. But if you haven't been to mine, it's rlescalambre.net. I've got all these links on there. Cookie-free, ad-free. Nobody's going to hound you. Feel free to use it. But on this one here, when we go there, I love this page. And I come up here, and here's my CAN Mode 6. Now, am I going to make sense of all of this? The answer is probably no. I'm probably not going to do much over here with the bits and stuff. I get an idea what they're presenting, some of the information I'm looking for ranges. What I'm really looking at is to match up the test on the car to see what it's telling me here. So I only put one page in here. I'm only going to the one page in here right now, but this can give you an idea whether it's on a D-cell, X-cell, idle, and you can match up your TIDs and mids and TIDs right here. It's all free. I encourage you to use it when you're looking at stuff. It can be kind of confusing at times, but it can give you an idea too as a starting point. And there's pages of this information for all the different mids and TIDs throughout the years of GM with CAN. So I really encourage you to use that. Okay, let me get back to, here's another one on OE website. Honda, for a long time, this information was free. You could get it before you went in the website. They would tell you the DTC, the DTC, which was really what you clued you in on. Here was the TID. You could go and find out a description, even if it was a little wordy at times because it was Japanese to English. You could find your values. And again, I'm not telling you to go get a calculator out and calculate this out, but this is what happened in pre-CAN when you wanted to get the nominal value of what the real value was. So that was available. No longer is that free. You got to search for that too. It's not as easy to find like it used to be. So keep that in mind. Mitchell, this is a 2018 Rogue. This is the information I get. Notice that each TID is tied to a DTC. That's really what I want to know. So if I come over here and I look at, I'll give you a common one. Let's see, where's the one I want? This one didn't have it. But if you get in here, you come in here, let me zoom that a little bit. You can go and see response rate, lean to rich, rich to lean. You'll see things in here that say decel, so that you know that you got a decel delayed response here is a decel. To get this test to run, you got to do the decel fuel cut. So while there's not a lot here, it's enough for what you need to know what the test might need. And if you're working with Nissan and you see those H after it, that's for hexadecimal. That is in lieu of the dollar sign. I call it the dollar sign in front of the number. So don't be miffed by that. So this can be helped when it's done right. And the other option you have, and I've been doing these more of these just to see how they're doing, is I've been running AI searches on specific vehicles. And overall, they've done a pretty good job of pulling up the MIDs and the TIDs I need with the values, as you can see, pass condition, fail indicator. But remember, the AI search is only as good as the information that's out there on all these engines that they're pulling from. But it can be a starting point. I did one on recently on a Subaru, and overall I was very impressed with what it came back with. So you got OEM websites, you got your subscription services, and you got your AI search if you need to dig into this further. Okay, I'm not saying this is what you got to do in every car, but for you to learn it, to get better at it, these are some options you have. Now, what does that all mean? Well, all this information makes sense. And I'm going to tell you, the simple answer is no. There's going to be some confusion on this. There's going to be some what ifs on this, but it is a starting point. It is available. You don't use it all the time, so get familiar with it. How can I make sense of Mode 6 information? Remember, it's supposed to report the last test results and maintain them over multiple key-off cycles until it's replaced by a more current number. And we're going to show you later that some of these systems, the numbers are actually replaced during the same trip. Some systems may require a key-off cycle. That's pretty much gone away, but if you work on some of the older cars, you may see that they don't update until you turn the key back on. Each time you want to look at Mode 6, you got to reestablish that handshake. So you got to make that connection to Mode 6 and think of it as a handshake. But even when your hand is connected, you're still going to only get one request. You actually have to break that handshake, put it back together, break it, put it back together. And that's called they call that a cyclical, but the tool is doing it for you. If you're working on any of the global aftermarket stuff, can the enhanced side show you this? Some do, some don't. Okay? The global will definitely show it to you, but they may not name it, especially on an older car. Snap-on's a good example of it. You go into the OE side, what Snap-on will do is Snap-on will link you back to the global side if you want to do it and go and look at it, and then you can come back to the enhanced side. Also, in generic, you may not get the name of the test. You may get the TID or the MID, depending on which car you're working on. And in this other case, on the right-hand side, you can see they're actually telling you idle catalyst efficiency test, but it's in raw number. You can see here, it's not converted telling you it's a percentage, but I got news for you. If I see 32,937 and I'm at 21,977, I'm only up 2/3 of the scale if you want to think of it that way. I'm moving on. There's no reason to calculate that out. There's no DTC with it. Move on. That's well below the maximum limit. No sense to dwell on it. If you're working on older cars, there were some cars like Honda that if you cleared the memory, and Nissan did this too, if you cleared the memory and you went into Mode 6, it would say no data display. That's because none of the tests had run. You drive the vehicle. As a test run, then they will list out on the screen. You got to go back and request it, but it will add it to the screen. Then the other problem we had with Mode 6 that we got rid of with CAN is you could turn the key on, clear the memory, turn the key off, turn the key back on, and all your TIDs and SIDs would say they passed. Car hadn't even run. That was a default. So under CAN, we've eliminated that by putting all zeros in there. We put incomplete in there, and we move on. Makes it much simpler. eScan has always done a good job with this. This is an older picture. But if you have eScan and you use it, Mode 6, what they're basically doing, what Bernie has done with that is he's constantly querying Mode 6. So I say to you is, if I'm doing the catalytic converter, I'm doing the O2, I'm doing the secondary error, evap, I don't need to constantly look at that. Those tests aren't running that frequently. But there are some tests like misfire. I'll show you later. There's VVT test that by querying it and basically making it cyclical, you don't have to keep going in and requesting it. It's doing it for you. And the tool I use, SilverScan, it gives me the option of doing cyclical, where it's constantly checking it for me, establishing a handshake for me, or I can put it on non-cyclical, where I don't want it to keep querying the system. So that's up to the tool, and not many tools have that. But it's something you need to be aware of when someone says, oh, I get constant Mode 6. It's because the tool itself allows you to do it. Okay, how does this all look? Hexadecimal from the PCM. That's where we're talking our 65,535 with alphanumeric stuff. Then originally we go to the scan tool with raw data. You'd see 0 to 255 minus 32767 to positive 32767, or you might see 06535. That was a raw number. We'd look to where we fell in the scale to see how we might be doing. Then Ford did it from the beginning. Toyota added it, and they went to conversions within their software. So if you had the Toyota cartridge for a long time, you could read their converted values. Ford did it from the beginning. You could see volts, amps, millimeters of mercury, inches of water, ratio, percentage, and some would just say unitless number. Okay? We fixed all that with CAN. So if you're on a car, here's hexadecimal presenting to the scanner. If I'm on a pre-CAN car that's presenting it this way, I'm looking at the minimum. I know this, I didn't tell you this, but I know this is the O2 heater circuit. Two new O2 heaters were put in this car. This is one of the banks. And the minimum to pass is 2621. I'm at 7472. Goodbye, I'm moving on. That's almost 3 times over the limit. Okay, that's how you want to use those numbers. But if you had the conversion factor, which you have in CAN, you can look at this, say 200 milliamps, I'm rounding it off, and it's at 570. Goodbye, job is done. I'm confirmed. It's fixed. I'm not going to have a comeback. And that's why I like to look at it. So again, look at it another way. The old TID and SIDS were the raw way. I mean, the hexadecimal way. Then we went to this where we have min and max with just raw numbers. And then we got the converted value. And this is our CAN cars today. Is it perfect? No, but it's pretty darn good. Now, I will say to you this. If you see a car like this in 64 and this is 50% over the minimum, goodbye, I'm moving on. But if I wanted to convert it, I can get the numbers, or I could have the scan tool that does it, and it can tell me I'm 20 degrees Celsius over the minimum. That means that EGR is flowing. It's flowing well, and it's not coming back. If we look at it on a chart here, you can see it even better. They said the line represents a minimum, the black line displayed on the scan tool. At this point, you've reached total failure. You need to get up to this point to at least pass. So why it's important to look at this number is, and I use this example, I'm sure there's a lot of you out there that have cleaned EGR passages over the years. And the question always becomes, how well do you clean them? And what I hear over the years from techs is how well ever the customer wants to pay or the boss is going to pay me to do it. So the issue here is, if we do the minimum and we just get over the minimum, we're probably looking at a comeback in a reasonably short amount of time. But if we're allowed to do the job correctly and we can get up here to this blue line or closer to this green line, we know the job is done. We're confident it's not going to come back, and we can move about our business. And that's why I want you to think about mode 6. Don't dwell on it too long, but ask yourself, am I just over the minimum? I just serviced this. It's just over the minimum. Or do I have an issue here? Or am I over? And I'm going to show this to you on a catalytic converter later. One of the first cases we ever had, because it's an eye-opener when you understand it, how much it can help you. Again, this is off the Toyota Lexus site. One thing I want to say to you about these conversion factors is, let's say Toyota decided on this vehicle to issue a reflash. And you go and pull this number off of the website to do a conversion. And this vehicle's had a reflash. Well, chances are in that reflash, that number's been changed. So, and I guarantee you that the OEMs do not go back to these websites and change the pages. I had someone working at Mitsubishi one time and flat out told me, hey, we have internal memos and not all those internal memos make it to the public. So some of these numbers don't get changed. You're stuck working with them. I'd stay away from that. I'd use it as a guide, but be careful of it because these could be wrong if there's ever been a reflash for it. Okay, this one here, good example. This is a pre-CAN car, and I see 0 out of 154. I just cleared the memory. Well, this car set the current value to 0. It's telling me that my limit is 60%. If the front to rear is 60% or over 60%, I'm going to flag a DTC. I drive the car. I see that it's ran and it completed, and I'm 4 out of 154. Goodbye, I'm gone. I'm not doing anything. But just to show you what that means is, look how good that cat really is. This is telling you, this is just showing you in real numbers. Okay, so that's how you'd use it if you're going to, but I would just look at this and say, I'm moving on. But be careful of something like this because it's rare you'll see flat out 0. And here's another one. This is the old way. Someone, instead of saying TID, they say time and they have a fail. Along with this fail, there should be a pending or confirmed ETC. And be careful, sometimes the numbers on the manufacturer websites are not correct on the older cars. So here's one for EGR flow. It was at 53 current. It's supposed to reach 64. So it's flagging a PO 401. So we got to go find that out. And we find out that it's not rising enough in temperature to satisfy the PCM. I didn't need this. I know that that's why I failed. The flow is too low. Temperature is not increasing enough. Okay. We go ahead and we clean the passages. We do everything we have to do on this vehicle. We run it. We see it's increased from, what do we say, 53 to 148. Goodbye. I'm gone. I'm done. There's no DTC. The monitor test is run. From a -7, basically, we're up to a plus 52 degrees Celsius. That tells us the repair is successful. This vehicle is not coming back. Period. And that's the peace of mind I want, is did I just fix it or did I really fix it? And this can show you. Now, here's where you have intermittent check engine light. This one had an intermittent check engine light, and it varied from morning to morning. It's the O2 heater. What was happening is there were some mornings where it was colder and the O2 heater was stressed a little more. There were other mornings where it was a little warmer and it was not as stressed and it was passing. But the number 80 and 81 are in seconds and it's telling me I'm really borderline. This is where I want to address the circuit and maybe focus on that component and see what's going on. And there was a DTC to go with it, was intermittent. And that's the kind of stuff I would be looking for if I saw this. Okay, this one we're going to look at the end and see how costly a mistake can be on this. Normally, you got to be careful this when you clear a memory on pre-can cars. This is a Ford. And Ford came up with the idea that they were going to put a nominal value in there. And if you look at this and you see 42 and it's passed out of 45, you're thinking, oh man, this cat is getting right near its limits. Well, I want you to hold that thought till we get to the end of this presentation so you can see how this could be a very costly mistake. And also over here, you see these fails? This was a default that Ford screwed up on, and their default on some of these were fail instead of pass. No DTC, no numbers to justify it. So you got to know your tool, you got to know your vehicle. Moving into mode 6 with misfire. Misfire used to be in mode 7 for some cars. Now it's in mode 6 for everybody. And it uses exponentially weighted moving average, which means it's going to take multiple drive cycles, and we use 10 in this case. It's going to filter out the misfires. It's going to average them out, and it's going to establish an average misfire over the last 10 drive cycles, which is nice. It gives us a history. Now, you're going to say, oh, wait, I work with cars with mills on. I've seen history codes. I've seen current codes. But what about the annoying code, a misfire that's bothering the customer? They can't get into you until today. They get into you today, and it's not happening. But it's happening a few times in the last few days. You go and look, there's no DTC, there's no counts on the OEM side or on the hand side. You go into mode 6 and you see some numbers in there, as I'll show you in a little bit on a Toyota. This is really good when you don't have check engine lights and you got the annoying little miss here and there. It can show you that something's been going on, but it won't flag a code. It'll stay in memory for 10 drive cycles. It'll be average out over 10 drive cycles. Plus, it'll give you a misfire for the current drive cycle. Okay, so here's an example. Down here, you can see this one here. It says misfires, current drive cycle. This one's ramping up pretty good, 6513, and it's being read continuously, which means I don't have to keep going out. I can look at this and I can see it changing. And it was for cylinder number 2. And here's an example of what's going on. When you use it on a continuous mode, and you can see it that way, or you keep checking it, I check it here, and this is for the last 10 drive cycles. Then I go again, and I see it's still increasing. It's increasing even more over the last 10 drive cycles. I know I have an increasing count, so it's confirming that I have an intermittent misfire. This amount of misfire over 10 drive cycles may not set a code, but it will piss off the customer. So the idea is this is your memory of what could have happened before. We didn't have a good system like that. And even I'll show you a little bit on the GMs, which is a little bit different. On this one here, some of you may have remembered current misfire on GM, history on GM. But it was always a reminder that history couldn't be established until current had set a DTC. Once current set a DTC, history could stay and stay around and give you a memory, even if there was nothing current. So you can see what CARB did. They took a balance of the two and said, let's put something in mode 6 that can benefit the technician. So now we got the opposite scenario here. Notice over the last 10 drive cycles, the numbers are going down. So that tells me what we've been doing looks like it's successfully fixed what we were working on. So this is how you can use it to your advantage. long before you hook up a lap scope or an ignition scope, if you have the capability of doing it on a particular car, this is a good starting point in the driver's seat to know what you're looking at. But remember, you got to keep querying it. If you have a scan tool that doesn't do a cyclical, you got to go in, go out, go in, go out. And it's okay. You could wait a little time in between and see what it does and then go back in. But if I see a decrease like this, I know I'm on the right track. Okay, and then on the next one, this one here is a misfire on a Toyota. It's recorded from a tool I have called SilverScan, and I put it into a file measurement program. And I'm doing this for teaching purposes. I'm not telling you to run out and buy this tool. I would never do that. But I want you to see, this was a Sienna 2017, 133,000 miles on the original plugs, coils. Cars maintain well, but every now and then you can feel something is not right. So let's take a look at this and watch the counts in here. You see the graphs over here, but you can see some of the numbers changing in here as we're doing this. And just watch how it moves around. It's giving you a live update. There we are up to 5, 6. You can see that cylinder's been up to 11. And this is for the current drive cycle. This is not the last 10. This is the current one on that line. OC is the current one. Okay? So, again, intermittent, just enough to annoy you and know that something's not right. And this thing with 133,000 miles on, when I got to it, the number 2 cylinder had one electrode broken off, and the boot was charred. The spark plug was loose in the threads. No one had ever touched that vehicle, and that cylinder started to loosen up. Fortunately, I got to it when I did before it blew the spark plug out of the hole, and that thing got a helicoil and a new set of threads. Redundant statement, and the car's fixed and it's running great now. And the misfires are next to nothing. Every car is going to show one every now and then. So the idea is, this is how you use mode 6 to your advantage before you pull out all your other tooling when it's intermittent. Obvious, the light's flashing, high numbers, go back to your basics and fix whatever's causing that. But when it's annoying and it's intermittent, think to yourself, hey, CAN-CAR, global, mode 6, I can go look at that. Okay, and again, that's the example there. Now, fuel system continuous monitor. Especially some of the people trying to get these. I'm hearing a lot of people still trying to get these for their smog tests, even though in California we don't need it, but there are other states that do require fuel system to be complete. Really what you're looking at here is the ability to identify air-fuel imbalance coming out of a cylinder. We've been using those codes since about 2014. To be honest with you, quite honest with you, they're poorly explained. A lot of manufacturers will tell you, oh, this is what the cause could be. They don't give you a lot of information on it. If you really want to learn this stuff, one of the best places to do it is on the Ford website, which I'm going to show you next. But basically, the cylinder, individual air fuel per cylinder says, I told that cylinder to fire, and look at my O2, how hashy it is, or look at my crankshaft speed, and notice what happened when that cylinder fired. Those are the two ways that they're going to measure for this imbalance by cylinder. Now that we're sequential, now that we're coil on plug, we can pinpoint down to the cylinder so much easier than we ever could. So to get through the fuel system monitor, I always tell people, one, it's got to do the air fuel imbalance test. It's got to make sure that the fuel trim has gone into a learn mode where it's updating learn. Is fuel control, total fuel control within a certain window? Has the car been driven a certain amount of time? I've got capture of these cars where some fire up in a few minutes, they're done. And I've got cars that take 20, 30 minutes to complete all this testing. That depends on what they started up on. But this is another thing in mode 6 that can be helpful to give you an idea where the issue might be. If I don't have an air fuel problem on a cylinder and it's something else, then I'm probably going to see that this test is going to pass. Okay, and here's how Ford explains it. They're basically looking at the frequency of the air fuel sensor, or the O2, as that cylinder fires. And I think this is a wonderful starting point for you. If you really want to know more about this, go into the Ford free site. I have that link on my webpage, and it's common knowledge out there. Most of the websites have it. It's OBD reference, and it's all free. And you can go into this information and read about how the system works. And everybody's using some form of this because they're all doing the same thing. But you got to learn from the ones that are willing to explain it. And I'll say one thing about GM and Ford, and even Chrysler over the years. I wouldn't be sitting here today if it wasn't for the amount of information they shared with us. The Japanese give their techs only what they need to know. And if you're a European guy, you grew up probably in the School of Hard Knocks with hopefully a master tech who brought you along. Or you did a lot of work on them and you just grew with them. That's the way I like to explain this. So this information is out there, and you can even AI search this. There's some pretty good stuff on this too. Okay, last few ones to wrap this up. I want to show you this one. It goes back a ways, but it just shows you when you don't know a lot about a system, if you understand it, what you can reason out. This was our very first, what I call real tackle of Mode 6 on a 98 Honda Accord with a PO420, 98K on it. The technicians already replaced the catalytic converter. Repair estimate was certain cat, $350. Well, he was pros with this problem. $350 parts and labor for an aftermarket cat. Some of you are chuckling, saying, "Well, that can't be too good." Or waiting for a 3-week back order on the converter for $1,200 plus parts and labor. That was pretty cheap considering what they are today. So which option did the customer choose? They wanted the less expensive cat. So the tech does his job. He goes out, drives the car, sets a cat monitor complete, returns it to the vehicle. 3 weeks later, it's back for a PO420. He's frustrated. He's done all the checks. So he drives out to the college when I was there. We ran it on the dyno 5 times, same load, 1 hour, passed 3 times, failed 2 times. So we showed him the benefits of understanding the simple things of Mode 6. In the time we ran it, the limit was 1,400. The blue is 1,400. His results were just above and below, which was telling us that cat was very, very marginal. So now we have the data to go back and either get that cat warranted or go to the dilemma of getting the cat, the OEM cat. Well, he convinced the customer that this should be done. They decided to put the cat on, the new cat on, the OEM cat. And you notice the 1,400, these were all down to 200. Now, if you think about a 1-to-7 ratio, this is where it would fail. Doesn't mean it's totally shot, but this is where it would fail. 1-to-7 ratio, this cat's got roughly about only 14% on the low side. It can go all the way up to almost 70% before it flags it. So this is what we call a catalyst degradation area. This cat is new, it's good, it's going to last this customer a long time. So verifying your repairs, intermittent problems, this is where it can be helpful, looking at the numbers while you're doing it. Now here's the one I was telling you earlier on the Ford, that if you don't know this stuff, it's going to cost you a lot of money. There's a long history to this car, but one of them was it couldn't get its monitor test to run for the California smog check. She's the original owner, had been doing it for close to 20 years, and all of a sudden it stopped running them. And it's been to multiple shops. When I got this car from him and he drove down here from the mountains to see me, he had already spent $4,400. And to make a long story short, we're going to focus on the cat first. That wasn't the problem, but what he was told to do based on these numbers, he was told to replace the cats because the numbers were so close to failing. And I said to my friend, I said, "Butch, your numbers are not close to failing. This tech did not understand Mode 6. Your monitor test is not run. This is a default value that Ford puts in the data stream, and they based it on that." I said, "I'd be willing to bet you didn't need a cat." Make a long story short, we found the problem with the car and why the other all the monitor tests except for EGR weren't working. It was a simple thing as an FTP that was stuck. And he changed that. All the monitor tests ran. The cat ran with one new cat here on bank 1. This is bank 1 right here with a new cat. I want you to pay close attention to that because look at bank 2 and bank 1. This car's got 150,000 miles on it or more. Look at the results now. This is the bank that got the new cat. This is the bank that had the original cat on it. And in my estimate, and I don't want to put anybody down, it didn't need either cat. They just didn't understand the numbers. If the monitor test hasn't run, don't use the number. And if there isn't a DTC tied to that, don't use the number. So I'm suspecting that this cat here, which is a big part of that $4,400, if he had bought 2 of them, he'd have been probably into the $6,500 range. And what wound up fixing this car was a $300 job to fix the FTP to get it back into range, and that passed all the tests. So know your numbers, look at this information and say what's real, what's not. Has a test run? If it hasn't run and completed, and there's a value in there, and there's no DTC, that's a default value. Monitor running means complete testing, pass or fail. And then this last one here, or next to the last one, This is my own Honda. I had a cat stolen in 2021. And at that time there were no OEM cats available, so we put an aftermarket proof cat by bar. Unfortunately, it was a Lev 2, not a Zulev. So I put this thing on the car, and I was getting intermittent check engine lights. That 18 is only part of them, as I saw them go all the way up to 22. So I did some research, and I had to do some research through BAR because there was a bulletin that was 10 years old for intermittent P0420s, but it was 10 years old, and I said, this doesn't have anything to do with aftermarket cats. So I had BAR run a check, and they said, well, all the Hondas that are passing have this calibration in it. So I went ahead and reflashed it, because the next time before I reflashed it, notice what happened. It passed. So I reflashed it, and what I want to say to you here is, if you have a bulletin for a reflash of a continuous test or non-continuous test in mode 6, look at the value, whatever the values are here, and only had a max. Look at it before you start and look at it after you've done reflashing it, because look at what they did. Legally, they upped that number and fixed that problem with the cat by changing the percentage ratio. That's one of them. I've seen them change other ways. I've seen Fords go from 70% to 80%, and the vehicles now pass and keep running fine. This was the first trip after that cat was installed. After driving it, this was the final reading. So I know the reflash, when I saw that number change, I was feeling really good about this, and I'm now 25,000 miles beyond that. I'm now 4 years beyond that, and I'm still sitting at 9, and it's a 5-year, 50,000 mile cat. I know I got plenty of life left in that cat. So before you do things, look at these numbers, get a baseline. If you can capture them, great. That's your database. Okay, now this one here, this is an O2. This is common on Nissans. This is a Nissan trying to run the O2 test. And I want you to look where we start real quick on this one. Notice here, they're all zeros. And now we've already populated the rear O2. So we've been doing something right for the rear O2, but the front one we're not. So now we got to ask ourselves, what kind of driving pattern do we need to get these to go? Well, let me finish this out and see what changes. And keep an eye on this one. I think you're going to see that this one here doesn't move at all. That's part of the issue, but more importantly, notice what's on the top. They're all zeros. Whenever you see all zeros, the first thing I got to question is, how am I driving the vehicle? So in this case, if you know Nissans, a lot of them, especially the 4-bangers, they need a 55 mile an hour cruise to run the front O2s. To get the rear O2s, they need about a 35 to 45 mile an hour cruise with a D-cell. Well, this car on a previous trip had accomplished some of that, but it was never taken up to speed, so these zeros are telling me nothing's running. Check your enable criteria. And if we were extending this out into a longer class, we'll have this in the next class. It'll be one of the examples in the next class to show you how you use this information to pinpoint when one of these tests doesn't run. And if you're working on any of these later model Nissans, especially the V6s, I'm telling you, hone in on mode 6 on TID 82 right here, and you're going to find out. And if any of you are on Diagnet, you're going to find out that we've been solving these cars, and I've got a case open with CARB to get them to look at this deeper, because these Nissans in 2020 are not running their O2 tests. If any of you have any problems with this, you understand what I'm saying. If you get any of those, let me know, because they're a real issue, and a lot of them hadn't been in for smogs yet, so CARB doesn't have a lot of information on them. So something to think about. Now the next one, here's a Honda with the rear O2 that hasn't run, and we're just going to let this run and take a look at the numbers, see what's changing, what's not. And you can see a bunch of them are moving around, but they're not all running around. They're not all completing. Okay? When I see something like this, my first train of thought is, this thing has a different enable criteria. And if you know the Hondas, a lot of you think, oh, I got to get these up to 45, 55 miles an hour and run them. Believe it or not, this 2022 Honda actually does these tests around town. This vehicle needs to be driving around stop and go traffic 25, 35 miles an hour, and that will run the O2 test. So when things aren't running, get back to the enable criteria and ask yourself, are none of them running, or most of them running, but I'm not finishing, and why aren't I finishing? And then the last one here, to show you that numbers are not always fixed in mode 6. If you take a look at this area right here, this is where the VVT monitor runs. And it's only looking for a target degree and it's looking for response time. But look at all the other tests and look at how many tests it does and reports after the monitor test runs. Now, I think I cut this one a little early, but you'll get my point here. So here we are in the monitor test right there, and you can see some of them changing. And that little diamond at the bottom is when the VVT completed. But if I were to drag this out and I had kept the movie longer, I cut it short for time, you would see that these Mode 6 numbers are constantly changing in the same trip in Mode 6, taking the most current value for each of these tests. So is Mode 6 fixed? The answer is no. This is kind of like the misfire page where these other tests are being run. They don't relate specifically to the readiness monitor test because it only requires target, degrees, and time response. But all these other tests relate to other DTCs, and you can see that they're running, just from the graph I got here, you can see they're running multiple times. So that means my Mode 6 data is going to be updating quickly, okay, as those tests run. Okay, so in a very short time, that's a really go over on this. And last thing to remember on Mode 6, understand its advantages and disadvantages. It's another tool in your toolbox you don't do every day, but we have a tendency to badmouth things we don't understand. So get a good grip of it. Identify if you're on a pre-CAN car or CAN car, two different worlds. The information you read from it typically is not live data. It's like a handshake where you can only communicate when the hands join and you can only get one piece of data. You have to keep breaking that or have something that establishes a link to keep it cyclical, to keep it updating like we saw in the misfire and we see on the VVT. Tests can be updated multiple times in the same trip. I have a GM catalytic converter idle test where they run those multiple times in the same trip. Ghost monitor tests, remember they exist, don't be fooled. They apply to evap, and if you see zeros, you're not as concerned unless the same type of test for large leak, if they're both zeros, you haven't run the test. If you're in O2 testing and you see zeros, then those tests haven't completed. Those are probably your blockers, and we're going to go into that in the next class. So if you've been through the first class on tips for running drive cycles, you see all the good and bad of Mode 6. In the last class on June 25th, we're going to do Mode 9, which is in-use performance tracking, and tie all this together in some case studies to show you how to do this, what I call driver seat diagnostics, working smarter, not harder. And we're learning these things that were designed, the engineers designed, that they never thought we would use. We've learned how to use them to our advantage. And the next webinar, I'll pull this all together, and you'll be a lot smarter for it. And that's how we've been helping people with these Nissans and some of these other vehicles, because we understand their history now. And if you want to register for that one, same place you registered for this one. We're good to go. I don't know if Dave's still out there, but for all of you who spent the hour with me, I know you got to get back to work. Again, I didn't have it in this webinar, but if you need my website, it's rlescalambre.net. It's a free resource, no cookies, no advertising. And if you need any follow-up help, my email is just rscalambre without the E on the end. You can reach me through my website at gmail.com. And please communicate with me and reach out for help if I can help you in any way. Other than that, I think we're done for the day. And you're free to get back to work, and I hope you enjoyed this.